friends, another day, another fuel cell. I'm really pumped right now because a few days ago I noticed that there's voltage in my microbial fuel cell, and I could tell because the LED was blinking, and every day since, the intervals between when the LED blinks has gotten faster, which means that the voltage is increasing. I finished some work today, so I thought I'd film a vlog where I test the voltage of my first fuel cell, and then we can make another fuel cell, a mud to electricity one as well, that we add either urine or salt to see if it increases the voltage in the fuel cell and how it affects that. And then we're going to design a dye to electricity fuel cell. Unfortunately, the mud is all dry, so I'm gonna try my garden to see if it's better there because we've been watering our garden, but everywhere that I've been going, like the forest, it's just really dry, and I tried to dig into it. It was not very successful. It's really loud out here, but I finally found some mud in my backyard, and I'm just sitting on the porch filming on my laptop while my phone charges, and Puppy is here with me. The first thing that I'm going to do is set up the voltmeter. So what you would do if you have one, it might be different depending on the kit, but what I did is you have two leads. I put this black lead into the port that says COM or COM beside it, and I put the red lead right on top. And I've set my voltmeter to the 200 setting. I lost the footage for the last clip, so I'm going to refilm how I set up to test the voltage from where I set up the voltmeter or multimeter, whatever you call it, with the black and red leads in the two bottom holes like so. I'll also turn on my voltmeter so that it's ready to go. With the fuel cell, I'm going to remove the LED and the capacitor that I had in there before. If you didn't put them in and are testing your voltage just from the wires being in the hackerboard right now, then you don't need to do that. This is where I take my transistor, and mine has protective pieces on the ends right now because it's new. So I'm going to remove both of those. And I'm going to bend my transistor so that I can put it into the pins on the hackerboard. And if it was already bent for you, then you're ready to go again. Where I'm going to put this transistor is on the 5th and 6th pin on the hackerboard. So if you're using a MudWatt like me that has the 5th and 6th at the bottom, and my anode and cathode wires are in the positive and negative pins. So now I have the transistor in there. With my alligator clips, I'm going to connect these to the leads connected to my voltmeter. I'm going to connect this green alligator clip or jumper cable to the red lead. I'm going to take one end of the red clip and attach it to the black lead. Then I'm going to take these other sides of the cables, and I'm going to clip them to each side of the transistor. Now what you do is you wait around 5 minutes as the voltage starts to go up on the voltmeter. If you get a negative reading on your voltmeter, what you need to do is switch the two cables that you put on the transistor to opposite sides. But I have a positive reading right now, and I'm going to wait for it to go up. It's been 5 minutes now, and we've landed at about 32.1 millivolts. It still fluctuates, like every time like it has a number, we'll go like 32.2 and then go back to 32.1, 32.2, and then eventually we'll like land at a number. So I'm gonna leave this attached here for a while to see if it keeps going up. And what happens with these fuel cells too is every day they can increase voltage for a certain amount of time, and then they just kind of hit a level where they're at their max voltage. And to also increase the voltage in your fuel cell, obviously having more electric bacteria will help with that, and adding other materials that can increase conductivity in your fuel cell. So the type of material in your anode and your cathode, adding salt, adding urine, things like that. I put the hackerboard or the MudWatt in the top of the container already. It basically just pops in like that. And I'm going to take my container, move this down a bit, put my soil into it and mix it with a bit of water until it reaches kind of a cookie dough consistency. So I'm going to mix this up with my hands, then add some salt inside. If you were adding urine to improve the conductivity, you should add approximately 1 to 5 milliliters of urine to your soil mixture. If you're adding salt, it would be 1 to 5 grams. I'm going to go with 3 grams, which is about half a teaspoon. So I'll be using my little measuring spoons. Now that our mud mixture is ready, I'm going to pop open this container here and start to assemble the mud to electricity fuel cell. The way that this works, and I had a tutorial for this the first time I built one in my last vlog, but it's kind of like making a sandwich or like a little burger that you're going to put into the chamber, which in this case is a container. And what's great about this one with the MudWatt is that it has measurements on the side. Ignore my muddy hands. Like this sandwich will look like essentially is you're going to have an anode and a cathode. So this is the anode and this is the cathode. And think of these as like burger buns. And in the middle, you're going to have around 4 centimeters-ish of mud in this case for the size of this cell that we're making. This is all ready to go. I'm going to wait 5 minutes to let this sit and then drain out any water that's in the cell if there is any. And then we'll put the lid on and set all the wires, LED and capacitor up. I removed some water from here and now it's time to put this lid on the cell. So I'm going to put the green wire into one side and the orange wire into the other. And then I'm going to put the capacitor in pins 1 and 2 and the LED into pins 5 and 6. The lid is on. This wire is going to go into the positive pin and this one's going to go into the negative pin. So anode is in the positive pin and the cathode wire is in the negative one. And capacitor in pin 1 and 2 and LED in pin 5 and 6. Then as this starts to generate its voltage, or the voltage is picked up, and hopefully the salt helps to increase the conductivity, then the LED will start blinking and we can also start testing the voltage the same way that I did with the other cell with the multimeter or voltmeter, whatever you call it, as soon as possible. So I could try tomorrow or the day after, but it's best to wait a few days for a significant amount of voltage to start building up. It's time to start plating MFC SN3, which stands for Microbial Fuel Cell Serial Number 3. It's the third cell that I'm making, and it's different than the last two because both of those were single chamber microelectricity fuel cells, which means that they were both one container each, and the container had mud as the contents. With this cell, it's going to be a dual chamber dye-to-electricity fuel cell. Well, it's not just dye-to-electricity, but that's what I'm calling it for short, which basically means that it's going to have two containers. One will be the anode, one will be the cathode. And in the single chamber, the anode and the cathode were all in that one container. So it has an anode and a cathode, two containers, and it's either attached by a salt bridge or some sort of membrane. And the goal of this cell is to figure out how to remove the contaminants from wastewater. And the goal of my project is to remove contaminants from dye wastewater and textile production. So this is going to be the first cell that has two chambers, and we'll be dealing with a wastewater product to clean that product and generate electricity through the process. I'm going to figure out some of the details of what to order, what I already have, and what the procedure will look like right now. I created a Notion page to plan out the fuel cell. So I made a little table of contents. If you click on it, it brings you to the different sections like materials, procedure, and once I actually start working on this, a part for any observations and notes I want to keep. At the top, I just put a little diagram of essentially what a dual chamber cell would look like. So on the left side, you have the anode, which would be filled up with the wastewater, or if you're also making a MudWatt or another sludge product, you would put it into that chamber. But for this one, it could have the dye wastewater. In the middle, you have a membrane or a salt bridge, and for this one, I'm planning on using a salt bridge, but you can use a membrane in the middle of the two chambers, like a Nafion membrane. On the right, you have the cathode, which has some water in it, so clean water, and an air pump that pumps in air. And you have electrodes in each of these that can be made out of different materials that are conductive. I think I'm going to use aluminum mesh, but I could use carbon as well. And then there's a little picture of some electric bacteria like Geobacter. I make all of my diagrams for things normally on Autodesk Sketchbook. I just find it easy to draw things on there, and it's also free, so if you're looking for somewhere to draw things, I recommend that. For the materials, I just listed out with a checklist everything that I'll need, and I sorted it into like assembly for the cell, for the contents like the water, the wastewater and the normal water, clean water, and what you need to test the voltage. I have a lot of the materials already, which is great, but what I do need to still get is the 1 liter containers, an air pump, aluminum mesh, and copper wire. I might have some of those things, but I need to check, and I'm just not totally sure, so I don't want to check them off yet. And I will attach this Notion or a copy of it with a full list of materials if this is something that you want to try out as well, without the check mark, so that you can actually read everything, because I think it's a little hard to read some of these things when they're crossed off already. In the procedure section, I inspired my procedure for this dual chamber cell by different designs that I've looked at, but mainly I took a lot of these steps from an experiment I watched by Paul Nyland and Marcia Rojas. So I linked theirs there that I can look at for any more inspiration or if I need help with my experiment. They use sludge in their experiment instead of wastewater, but I'll be using wastewater inside of one of my chambers. So with the procedure part here, I also sorted this into different parts, like preparing the contents of wastewater and clean water, preparing the dual chamber architecture, which is the containers, salt bridge, electrodes, and then actually assembling everything all together. And then, like I said at the bottom, I just have a section for observations and notes that I might have once I actually start doing this, so I just have a place to keep that all organized with everything else.